Hey everybody, Dr. Rob here. The brain-immune connection. I was reading yesterday Scientific America, and man, this article was great. It encapsulated so much of what I do in my office and so much what I talk about on Facebook and out on the lecture circuit. So it really imbued me with a lot of enthusiasm to really share what I saw in that article, and it excited me in that now Scientific America is talking about what we're talking about in everyday life. Outstanding. So do me a favor, if you like what you see, like it, share it, make a comment. Feel free to make a comment. We're going to answer any questions or any comments when I'm all done. This is going to be a quick one because we're going to talk about the brain-immune connection. Number one, the innate immunity. So the immune system has two different immune systems. The first one is innate immunity, in that it is a more primitive element. It's what we've had since day one. It's what we start with. It's like skin, it's mucus, it's intestinal barriers, it's urine, it's anything that's innate to us that we get immediately to protect ourselves. It evolved billions of years ago. We didn't have to develop it. We came with it. It was given to us. It's the first cell to detect and dispatch and to go attack any pathogen that comes in towards us. So our innate immune system is literally our internal born defenses. It's the first line of defense against pathogens. It's our first line. So it's very interesting. People don't look at the immune system in two different facets. They just look at the immune system. And as we go through this, you're really going to understand that when our immune system functions well with good chiropractic, functional medicine, we can have the ability to be a healthy, functioning organism. When we have adverse effects and our immune system works aberrantly, doesn't work well, that's when we get sick. That's when we actually get autoimmunity. So the second type of pathogen, and one more time, innate immunity initiates inflammatory response. So you'll get some inflammation. The second one I want to talk about is the adaptive immunity. It actually evolved after innate. It is essentially T and B lymphocytes. So what happens here is the lymphocytes come in and they start with neutrophils. And these neutrophils, not trying to get too technical, come in and start attacking the area. Neutrophils and leukocytes come in at the time of acute inflammation. Ultimately, macrophages are supposed to come in with proper signaling, will stop the inflammatory process. It actually recognizes specific pathogens and it attacks them also. The biggest problem, and make note of this, is adaptive losses. That leads us to autoimmune. When this section, adaptive immunity, doesn't work and changes, that's when we get autoimmunity. Autoimmunity is when the body attacks itself. So let's give you some specific examples. It attacks itself because of, number one, something like a rheumatoid arthritis. Number two, believe it or not, osteoarthritis. Number three, thyroid, diabetes. These are all autoimmune diseases that are failures in what we call our adaptive immunity. We're going to get to the immune system, and we're going to get to the immune system in the brain as we build towards this. It's quite exciting. The recent findings, I want to have a breakaway here, or a breakthrough, almost a watershed moment. Is immune systems hierarchy active in the healthy brain and essential to functioning? So these immune systems are critical in the brain. So the immune system, 70% of our immune cells are in our gut. Our gut is in a complex in coordination in a bidirectional manner with our brain. That specific conversation in bidirectionality comes from what we call the vagus nerve. So that really speaks to that. The vagus nerve is actually talking to the brain. Interesting. So it's a signaler. It's a neurological signaler that speaks from the gut to the brain. Let me flip this over. And let's talk about this blood-brain barrier. So the blood-brain barrier, it protects the brain, the blood-brain barrier. We've got a gut barrier. We also have a blood-brain barrier. The gut barrier and the blood-brain barrier are, without question, made up of the same proteins. People don't look at the blood-brain barrier and understand that's a critical element. So when you get leaky gut, which is also, you could conceivably think, a lead to autoimmunity, you're also going to have damage to your blood-brain barrier. Blood-brain barrier, astrocytes reinforce the barrier. The astrocytes reinforce the barrier. The astrocytes are made up of what we call glial cells. Again, not trying to get too technical. Your glial cells are in your spinal cord, and they reinforce the blood-brain barrier. When those astrocytes are damaged, or they turn and start attacking the blood-brain barrier, you have a compromise to your blood-brain barrier. Meninges, they're actually cells around the membrane. They protect the membranes of the blood-brain barrier. They actually contain lymphatic vessels. Containing lymphatic vessels, they're speaking to each other. And finally, they carry peripheral immune cells that communicate with the brain cells. Those are cytokines. Where do cytokines typically come from? Once again, our gut. So again, our immunity is speaking to our brain, but it's speaking to our brain through our gut via the vagus nerve. Vagus nerve gets stimulated, speaks to the gut. The gut has something called like toll-like receptors 2 and 4. They release cytokines. These cytokines come up all the way through the body into the brain, damage the blood-brain barrier, and give you what? A compromise in the blood-brain barrier. Finally, cerebral spinal fluid from meninges enter the paramecium through spaces surrounding blood vessels supplying brain and carry the cytokines from the peripheral immune cells deep into the brain to influence neuronal behavior. Whew. That sounded pretty heavy. Well, here's what essentially it said, that when you have a compromised gut or you have something going on in your immune system where it's working aberrantly, it signals up to your brain, it signals via the vagus nerve, leaving cytokines. These cytokines come to the blood-brain barrier, damage your blood-brain barrier, damaging your astrocytes, getting into your blood-brain barrier, getting into your brain, and getting into your cerebral spinal fluid. So if there's something wrong with your gut or your immune system, you're ultimately going to damage your brain and your cerebral spinal fluid. The body's all interconnected. You got to take care of your gut health. Take care of your gut health will lead you to taking care of your brain health. This was a little technical, but when you see Scientific America talking about it, the takeaway is if you take care of your gut, you'll have good brain health. If you take care of your brain, you'll have good gut health. Do we have any shout outs or anything?
Nope,
it's no questions today. I can't believe it. Guys, this is great. This is what we're talking about. Anybody have any questions a little later? It's a quick little Facebook Live today. Please feel free to reach out to me. Remember, like, click, and share. Dr. Rob, every Tuesday, always yours in health.